Number 9. Monthly mortgage payments can be found by using the formula below. Now, that formula looks awful, but they do go ahead and tell me what each of the variables within the formula represents. So I should be able to substitute in fairly easily. In the question, the Banks family would like to borrow $120,000 to purchase a home. They qualified for an annual interest rate of 4.8%. Algebraically, determine the fewest number of whole years the Banks family would need to include in the mortgage agreement in order to have a monthly payment of no more than $720. So, let's go ahead and start substituting in. M is the monthly payment, and they want a monthly payment of no more than $720. 720 equals. P represents the amount borrowed. They would like to borrow $120,000. $120,000 times R over 12. R is the annual interest rate. In our case here, the annual interest rate, 4.8%. 0.048 divided by 12 times 1 plus 0.048 divided by 12 to the power of n, the number of monthly payments. Well, that's what we're actually looking to solve for. N over 1 plus 0.048 over 12 to the power of n minus 1. Alright, what can I simplify to make this look a little bit easier? 0.048 is divisible by 12, so I could do that step. 720 will equal 120,000 times 0.004 times 1.004 to the power of n over 1.004 to the power of n minus 1. Now, at this point, what I can do is put this over 1, and I can cross multiply. The 720 will multiply this value. 720 times 1.004 to the power of n. The 720 is also going to distribute to the negative 1. 720 times negative 1, negative 720. 1 times everything, well, that's just going to remain as is. If I want, I can take the 120,000 and multiply it by my decimal value though. So the 120,000 times my decimal value of 0.004 becomes 480, and that still multiplies 1.004 to the power of n. Now, we need to get our equation set up. It's going to look a little bit different, but I'm going to treat this as a common variable, or as a like term. One side of my equation has a 1.004 to the power of n. So does the other side of my equation. I'm going to go ahead and subtract the 480, 1.004 to the power of n from each side. I can treat those as like terms. 720 minus 480 leaves me with 240 of the 1.004 to the power of n. At the same time now, to save a little space, I'm going to take this negative 720 and I'm going to move it to the other side of the equation. And when I bring it to the other side of the equation, it becomes positive. Let's see. Well, my next step in solving, I can divide each side of the equation by 240. 1.004 to the power of n equals 3. At this point, I have an exponential equation written in its simplest form. In order to solve, I'm going to use a logarithm. I'm going to take the log of each side and then use the properties of logarithms. I'm going to move this exponent out in front. At this point, to solve for n, I need to divide by the log of 1.004. We end up with n equaling 275.2, and this is payments. Well, my payments are made every single month. So what I would now need to do is take my number of payments, 275.2, and divide it by the 12 months. This tells me that I would need to take my loan for a total of 23 years.